experience, Lasco Umformtechnik is known throughout the world as manufacturers of the most modern machine tools and equipment for solid and sheet metal forming and powder metal pressing. The corporate philosophy is one of continuous advancement. Decades of technical experience in applying the fruits of research and development effort have led to the highest levels of efficiency. Included in the product range for forming technology are hydraulic presses for hot and warm forging, hydraulic double-acting forging hammers, hydraulic presses and hammers for sheet metal forming, hydraulic cold forging presses, direct drive screw presses, powder metal presses, and special purpose hydraulic machines. Lasco's range of hydraulic-powered, double-acting hammers with a one-piece frame, known as the Series HOU, are technically and commercially ideal for a wide spectrum of typical forging applications. The use of the most modern hydraulic power system, control technology and sensing devices are the culmination of a long development program that has brought the classic forging hammer to a high-precision forming machine. The characteristics of the die forging hammer are high deformation speed, short die contact time, low power consumption, consistent low energy delivery, high production capacity, low investment cost, great flexibility and low maintenance. The forging hammer is the oldest type of forging machine in the world. The earliest drop hammers employed friction rollers and belts or boards to lift up the ram to which the upper die half was attached, and the quality of the work they produced was very much dependent on the experience and skill of their operators, whose manual control determined the drop height of the ram and so the energy delivered by each blow. In 1951, Lasco developed the world's first hydraulic hammer drive, which was given the German patent number 974854. The ram of the HOU hammer is hydraulically accelerated to a velocity corresponding to the blow energy required, and so drop height loses its significance. In fact, the start position is always the same, with acceleration being carefully controlled to give a precise impact velocity of up to 5.5 meters per second. The development of the hydraulic drive has enabled the use of the compact one-piece U-form frame. The drive in block design is encapsulated within the cast steel head with almost complete absence of pipework, and so is highly suited to the rough forging environment. Energy is transmitted by a forged piston rod to the hammer ram, which moves in an X-form guide system within the frame. The choice of a direct mounting vibration isolating foundation system avoids the need for massive concrete work and fulfills the requirement for vibration-free and noise-reduced operation. In the 1950s, Lasco was the first hammer maker to offer the one-piece frame. The short rammed stroke enabled the frame design to reach ideal form and mass distribution, resulting in great stiffness. The frame is cast in high alloy steel and undergoes precisely controlled heat treatment. The ratio of masses of the ram and frame are carefully chosen to optimize blow efficacy and minimize critical loading on the frame. The standard design includes a generously proportioned heat-treated anvil insert keyed into the frame. The X-form guidance system is not sensitive to temperature difference between the ram and the frame, and so enables minimum sliding clearances to be maintained, a prerequisite for precision forgings free of mismatch. hammerhead carries all hydraulic drive components while also serving as an oil reservoir. Axial piston pumps produce the system pressure, which is kept constant by the use of hydraulic accumulators even for long blow sequences. The blow valve releases and controls the hammer blow. The opening time of this valve, precisely controlled between 120 and 180 milliseconds with a consistency of plus or minus 1 millisecond, determines the energy of the blow. Forged blocks unite the various hydraulic control elements, eliminating almost completely the need for connecting pipework, a potential source of leakage. A supply duct carries power and control cables up to the drive, and also the hydraulic hoses that circulate oil continuously through the filter cooler unit standing next to the hammer. The complete drive unit is vibration isolated from the frame, but connected to it by strong anchor bolts with pre-stressed cup washers. The forging hammer component that carries the highest load is the piston rod, and as a result of many years' experience and scientific study, this is designed by Lasco with low mass and good flexibility. Its means of fixing to the ram is secure and free of stress-raising points. In this application, a Lasco HOU double-acting hammer is used to forge hand tools. The hammer is presented with blanks, stamped from sheet, with a form giving the material distribution required. The blanks emerging from the blanking press are transferred to a furnace for heating to forging temperature. Forging is completed in 4 hammer blows, 2 flattening and 1 each in the blocking and finishing die impressions. Reliability and low running costs are characteristics of Lasco die forging hammers. The efficiency of the hydraulic drive in comparison with pneumatic or steam-driven hammers shows huge savings in power costs. The electric power consumed by a single pneumatic hammer can drive 4 hydraulic hammers of comparable capacity. Furthermore, the combination of drive and control technology employed in the Lasco hammer brings a 30 to 40% increase in productivity. Hundreds of pneumatic and steam-driven hammers around the world have been converted to the Lasco hydraulic drive to obtain the clear advantages inherent in this design. All the control techniques of a new hammer become available with such a conversion. Lasco double-acting forging hammers are available in blow energy capacities from 10 to 200 kilojoules. Applications requiring blow energies greater than 200 kilojoules are generally better served by hammers employing the counterblow technique, and Lasco have delivered the first and the largest hydraulic hammers of this type. In a counterblow hammer, the kinetic energy of the lower ram and tooling is equal and opposing that of the upper ram and tooling. The Lasco Series GH hydraulic-driven counterblow hammers have upper and lower rams of greatly differing masses in the ratio between 1 to 4 and 1 to 5. This means that to equal and oppose the energy of the lighter, fast-descending upper ram, the heavier lower ram must only rise to meet it at a velocity of 1 to 1.2 meters per second. Modern electronic components for measurement and control are essential for taking full advantage of the possibilities offered by the hydraulic double-acting hammer. All Lasco hammers are equipped as standard with a programmable logic controller featuring a high-capacity CPU. All operating elements, together with a color display unit, are contained in a compact swing-out control console. Forging blows can be delivered individually or as part of a programmed sequence initiated by a foot switch. The number and energy of each blow in the sequence is programmed along with any pauses that may be needed. The controller offers user-friendly operation, clear fault indication, practice-based diagnostics, and the possibility of acquiring and saving operating data. A modem for remote diagnosis is standard equipment, and Lasco offer the option of an internet-based diagnostic system by which optical as well as digital information can be transmitted by the use of video cameras. The Lasco model HOU occupies a special position among die forging hammers, distinguished by its high forming velocity and short die contact time. It offers more forming capacity for the same investment cost and represents the ideal technical and commercial solution for a wide spectrum of typical forging applications.